Welcome to AI Podcast. I'm Michael, and with me is Sarah. Today we're translating a new arXiv paper into a clear conversation. TLDR first. The paper introduces a system called HERCULES that builds a hierarchical clustering tree using recursive k-means, then uses a large language model to title and summarize every branch. The result is a hierarchy you can actually read, and on a classic text benchmark it comes close to strong flat baselines while adding an interpretability layer.
That's helpful already. So it's not just grouping documents, it's naming the groups so people can skim and get the gist. Who's behind it?
It's led by Gábor Petneházi, with co-author Bernadett Aradi, both at the University of Debrecen. The paper was posted in 2025 and revised in early September of that year on arXiv.
All right. Before we dive into their method, what problem are they fixing here? Hierarchical clustering has been around for ages, but the trees can be tough to read.
Exactly. Hierarchical clustering gives nested groups that quickly become opaque. You might get reasonable splits mathematically, but no quick way to understand what each branch means. Large language models are good at summarizing, so the authors integrate an LLM into every level of the hierarchy to generate short, meaningful titles and descriptions. That turns a tangle of clusters into a readable outline.
Makes sense. And what had people tried before this?
There's prior work where LLMs add constraints, relabel clusters after the fact, or help with data curation. Those approaches are usually piecemeal. HERCULES bakes the summarization step into the pipeline at every level. They also explore an optional centroid resampling refinement from earlier hierarchical k-means work. But their focus is on interpretability rather than enforcing uniform cluster sizes.
So how does HERCULES actually work in practice?
Think of it as two stages that alternate. First, you compute embeddings for your items. Then you build the hierarchy by recursively running k-means, moving up the tree by clustering centroids of the level below. After each split, the system prompts an LLM with representative samples and simple stats to write a concise title and a short description for each node. They test two representation strategies. In direct mode, the clustering uses the original item embeddings, and parents inherit centroid vectors. In description mode, they embed the LLM written summaries and cluster those, letting the model's semantics influence the higher levels. Users can also provide a small topic seed to steer the style of the summaries. The code is open source as a Python package called HERCULES, and there's an interactive viewer to explore the tree.
Nice. What did they evaluate on and how did they compare it?
They use the classic 20 newsgroups dataset, about 19,000 posts across 20 topics, with the usual cleanup. They fix a 3-level hierarchy so that one level has 20 clusters, which lets them compare to the known categories. For baselines, they include older text pipelines like LSA combined with k-means or agglomerative clustering, and stronger baselines where you do flat clustering directly on modern embeddings. To understand what matters, they run a factorial ablation that toggles 5 switches: direct versus description mode, cloud versus local embeddings, cloud versus local LLM, the resampling refinement on or off, and whether the topic seed is active. They repeat runs with different random seeds and use a standard non-parametric test to check main effects. Metrics include the usual external measures for clustering quality, internal separation scores, a summary-based distinctness score computed on the descriptions, plus a topic alignment score and runtime.
That sounds thorough. So what's the headline result?
Big picture, HERCULES. In direct mode lands close to a strong flat k-means baseline on the same embeddings, while giving you something the flat method does not, which is a readable hierarchy with clear titles and summaries. The goal here is to add interpretability without losing too much quality, and they achieve that.
And from the ablations, which knobs really mattered?
3 stood out. First, direct mode beat description mode on this dataset, both in external quality and in how distinct the summaries were. Second, the cloud models helped. The Cloud LLM produced clearer, more separable summaries and was over 7 times faster, and the cloud embeddings aligned better with the topic seed. Third, turning off the resampling refinement produced more distinct summaries. It seems that chasing uniform centroids can nudge the partition away from natural boundaries when your goal is human-readable summaries.
Do they share any qualitative examples of the hierarchy?
Yes. At the top level, you see broad themes like sports, hardware, and a combined religion and politics branch. As you drill down, those split into intuitive topics such as baseball, X windows, and for sale posts. There's also a small cluster of low content or empty posts that the LLM labels clearly so you can set it aside. That is the practical value here. You can scan the tree like a table of contents.
Let me push a bit. What are the caveats I should keep in mind?
The experiments are on a single benchmark, which is informative but dated, so generalization to modern corpora or images and numeric data remains to be shown empirically. Runtime comparisons are not apples to apples because HERCULES uses an embedding cache and makes LLM calls for each node. And the best setup relies on proprietary cloud models, so reproducibility and cost need to be considered. Finally, the current automatic choice of how many clusters per level is fairly basic and looks at each level locally rather than optimizing the whole tree.
If I were to adopt this, what's the practical takeaway?
You get a navigable outline of your collection without hand labeling, which can accelerate discovery and triage. If you want the best summaries, budget for the LLM calls, and expect flat clustering to be a bit faster when you do not need a hierarchy.
What about the description mode that trailed here? Could it shine somewhere else?
Possibly in very noisy settings where a strong generative model can impose cleaner semantics. The authors suggest better prompts or stronger models might help, and another angle is training summary-aware embeddings so that the separation in the vector space matches the way summaries are written.
Let's wrap with future directions. What do they propose, and what would you add?
They point to smarter global decisions about how many clusters to make at each level, testing on larger and more recent datasets, true multimodal fusion within one run, streaming or incremental updates, and clearer end-to-end timing. I would add user studies to measure whether LLM-titled hierarchies actually speed up real tasks, along with cost versus quality curves that show how far you can go with small open models before moving to cloud options.
Good checklist. Final takeaway for busy listeners?
HERCULES shows you can keep most of the clustering quality you get from modern embeddings and gain a readable hierarchical outline written by an LLM. If you care about interpretability and discovery, that trade can be worth it.
Thanks, Michael. And thanks to everyone listening. If you work with big text collections, this is one to try.
That's it for today's AI podcast. See you next time.